going to end up with 2 inequalities as my answers. What name did we use to describe 2 inequalities that were put together? Did this yesterday. What word did we use to describe 2 inequalities put together? Compound. So what we're looking at, absolute values are basically compound inequalities because my answer will have 2 inequalities. Because absolute value means I'm going to have usually two answers. In this case, my answers are going to be inequalities. So we're going to have 2 inequalities as answers. So basically, we're going to have compound inequalities, but we have to do a little bit of work first. Okay? There are 2 different cases you may have. Okay? First one is the absolute value of x is greater than 5. Okay? This is an or compound inequality. Colton, keep your head up, please. Thank you. This is an or compound inequality. So, or compound inequality, if your absolute value is greater than a number, then it is or. Okay? So when your absolute value, and we'll talk about this more when we look at examples, when your absolute value is greater than a number, this is going to be an or compound inequality. When I graph an or compound inequality, what will it usually look like? We did it yesterday. When I put an or compound inequality on a number line, what will it look like? Going away from each other, okay? So we're kind of combining absolute value equations with compound inequalities like we did yesterday, okay? So let's go ahead and graph this. So let's think about what this means. What this means is absolute value is the distance from 0. So I want numbers that have a distance greater than 5 from 0. That's what absolute value means, okay? So what 2 numbers on a number line have a distance of 5 from 0? 5 and negative 5. So 5 and negative 5 have a distance of 5 from 0. Remember, that's what absolute value means, guys. So that's what absolute value means, is the distance away from 0. So the 2 numbers that have a distance away from 0 are 5 and negative 5. So I'm going to put points. This is not an equation, so it's not just x equals negative 5 and x equals positive 5. These are inequalities. I want my distance from 0, which is the absolute value, to be greater than or equal to 5. So which ways do I shade to give me my distance from 0 being greater than or equal to 5? Right. Let's look at this negative 5. If I look at the negative 5, which way will I shade that will give me distances greater than 5? Left. So if I shade left, that will give me numbers that when I take the absolute value of will give me greater than 5. Those are numbers that have a greater distance than 5 from 0. Let's look at the 5 over here. Which way do I shade at a positive 5 to give me numbers that have a distance greater than 5? Right. Which makes sense. This is why it's an or statement, because it's going in opposite direction like we talked about yesterday. So when you have the absolute value is greater, if it's helpful to think about it, greater, if you spell it wrong, if the absolute value is greater than a number, then it is an or compound inequality. And then the second case, the absolute value is less than or equal to 8. If it's less than, if the absolute value is less than, you can spell it as less than. If it's less and, so you can think about it less, if you spell it like less than, but instead of and, you put and. So less than are and compound inequalities. And what do we know about the graph usually of and compound inequalities? It's where they meet or they overlap. So we're thinking my number line is going to overlap. Let's graph this real quick. Absolute value is less than 8. Okay? Absolute value means the distance from 0. What 2 numbers have a distance of 8 from 0? 8 and negative 8. 8 and negative 8. So we're going to put a point at 8 and put a point at negative 8. This is not just an equation. So a point is not just my answer. It's an inequality. So I need a shade. Okay? Let's think about this. I want distance to be less than or equal to 8. Distance from 0 to be less than or equal to 8. So if I look at negative 8, which way do I shade that will give me distances less than 8? The middle, right. If I shade to the right, that will give me distances less than 8. Let's look at positive 8. Which way do I shade that will give me numbers that have a lesser distance than 8? Left. And so it's shaded in the middle. So like we did yesterday, this is and, so they're going to meet in the middle. So if your absolute value is less than, it is an and statement like we did yesterday. Okay. Any questions? Okay, let's look at number 2. Let's look at 2 real quick. Let's look at 2. First of all, if I look at 2, first thing you're going to want to do is to figure out if it's an and or. So if I look at 2, the absolute value is alone. The absolute value is less than 8. So is this an and or? And. The absolute value is less than, so it's an and. So that's the first thing I do is I say, okay, is it an and or? The absolute value is less than, so it's an and. Now, with the compound, or with the absolute value equation, how did I get my 2 equations when I had an absolute value equation? I took it and split it into 2 equations. How did I do that? I took the middle part and I did what? Absolute value equations. Think back a couple weeks. I took the middle part. I made my 2 equations by taking the middle part and doing what? Set it equal to negative and positive. We're going to do the same thing. So we're going to take my middle part, but we're not going to set it equal. We're going to use this symbol. So x is less than a positive 7. So you do the same process as with absolute value equations. Take the middle part, set it less than 7, and then we're going to set it to a negative 7. However, this is an inequality. So when I make that 7 a negative 7, I have to do what with the symbol? Greater than. You switch it. So that's the difference. Same idea. You take the inside part and you set it equal to a positive and negative, but now we have inequalities. So you keep x is less than 7, and then when you make it a negative 7, you have to switch the symbol. Guys, keep your heads up, please. Colton, keep your head up, please. Colton, keep your head up, please. Okay, now let's graph this like we talked about yesterday. This is and, so I'm thinking they're going to meet in the middle. X is less than 7. How do I graph x is less than 7? Less than 7. How do I graph?
X is less than 7. I have 2 inequalities here. Open circle 7, shade to the left. Like this is just like what we did yesterday. Okay, x is greater than negative 7. How do I graph x is greater than negative 7? Okay. Open circle negative 7. If you want to put it above it like I showed it yesterday, I don't care, so it looks a little less confusing. X is greater than, so I shade to the right. Now this is an and, so I'm worried about where they intersect, or where they cross, where they overlap. So where do the shadings overlap? Where on my number line do the shadings overlap? Not everywhere. Between 7 and negative 7, so shade that in darker somehow. Okay, now if I do interval notation like I did yesterday, if I do interval notation, you start from the left. This is my answer, the part in the middle. You start from the left and you go to the right. We're only going to have one interval notation because I only have one interval. It's not 2 going opposite directions, it's 1 in the middle. So start, what's the left number? Negative 7, comma, 7. So I go from negative 7 to 7. And then how do I decide whether it's parentheses or brackets? Open or close. It's open circle at negative 7, so it's a what? Parenthesis. Open circle at 7, so it's a parenthesis. So it's very similar to what we did yesterday, except you have to come up with your 2 equations first. Okay, any questions on that?
No. Seems easy.
Okay, we're going to look at another one. Let's look at another one.
When you're doing absolute value, you switch the sign.
Correct. Yes. Yep. Let's look at 5 real quick. Let's look at 5. If I look at 5, the absolute values alone, so we can go ahead and decide if this is going to be an and or. Is this going to be an and or compound inequality?
or why? The absolute value is greater, so it's or. Which means when I graph it, it should be going in opposite directions. Guys, keep your heads up. Let's go. I was up with the kid a lot last night, so I understand I'm tired, but sometimes you gotta do what you gotta do. Okay, so the absolute value of 3x is greater than 12. Guys, let's go. Heads up. Logan, head up. Thank you. Where you're not looking at the board. So let's go ahead and create my two inequalities. So this is absolute value. So I take the middle part, greater than a positive 12. So the first one, you just lose the absolute value and change nothing else. So 3x is greater than 12. My second inequality is your middle part, and it's going to be a negative 12. But since I'm dealing with an inequality, when I make the 12 a negative, I have to switch the direction. Okay? So same idea as with the absolute value equation. The middle part, set equal to a positive, which in this case is just greater than 12. And then the middle part is less than a negative 12. When you make it a negative, you have to switch the direction. Any questions so far? Now this is exactly like we did yesterday. How do I solve? 3x is greater than 12. How do I solve it? Divide by 3. So x is greater than 4. Okay, let's do the next one. Divide by 3. X is less than negative 12 divided by 3. Negative 4. Okay? So once you split it into 2, it's just like you did yesterday. Let's graph these. How do I graph x is greater than 4? How do I graph x is greater than 4? Open at 4. Shade to the right. How do I graph x is less than a negative 4? Open at negative 4, shade to the left. This is or, so I'm expecting them to go in opposite directions. Now, when I do interval notation, how many intervals do I see on my number line? 2, one on the left and one on the right. So I'm going to have 2 intervals, and I'm separating them with the word or. And you will usually have 1 interval, or you're going to have 2 because they go in opposite directions. Let's start with the left one. I don't have a specific starting point, so I put down what? Negative infinity goes to negative 4. Parenthesis or bracket. Always parenthesis with infinity. It's an open circle at negative 4, so parenthesis. Let's look at my interval on the right. Start from your left point. I start at 4. I don't have a specific ending point, comma, infinity. Parenthesis or bracket. Yep, open circle at 4, parenthesis, infinity always gives parenthesis.
You would have to put that or in the middle.
Yes, I want to see that or, so make sure you put that or. Okay, let's look at one more. Let's look at 6, and then we'll finish this up. Okay, let's look at 6 real quick, and then I'll let you start the homework. Let's look at 6, top of the back page. Okay, the absolute value is alone. It's isolated, so we can decide whether this is and or. Is this, by looking at the symbol, and or? The absolute value is greater or equal to, so this is or. So it's going to look just like yesterday. We're thinking they're going to go in opposite directions like we did yesterday. Absolute value time. Let's get rid of it. Okay, I take the inside part. My first absolute value will look like what? (2x plus 5) is what? Yep. The first inequality comes from just dropping the absolute value. When we had an equation, we set it equal to a positive. You just leave it the same for this one. The second one, you take the inside part and you set it equal to a negative, but since it's an inequality, when I make this a negative 3, I'm going to have to do what? Flip the sign, so it becomes less than or equal to. So that's the only thing different. It's the same idea as with equations, but you're dealing with inequalities, so you have to switch the direction when you make it a negative. Okay, 2 inequalities we know how to solve. Don't make this harder than it is. There's a few tricky things you have to remember, but basically it's stuff we've done before. Let's solve this. What did I do first to solve the inequality on the left? Subtract 5. Subtract 5. 2x is greater than or equal to 3 minus 5? negative 2. Divide by 2. X is greater than or equal to negative 1. Next one, minus 5, minus 5. 2x is less than or equal to negative 8. Just a second. Negative 3 minus 5, negative 8. Divide by 2. X is less than or equal to negative 4. Okay, so solve these two like normal. This is an OR. So when I graph these on a number line, I'm expecting them to go in opposite direction. Let's graph them. X is greater than or equal to negative 1. How do I graph x is greater than or equal to negative 1? Close circle at negative 1, which is between 0 and negative 2. X is greater than or equal to negative 1, shade to the right. Next one, x is less than or equal to negative 4. Filled in circle at negative 4. X is less than or equal to, shade to the left. Or should be going in opposite directions. If you do this on your homework and you notice they're not going in opposite, and then have us look at it. Okay, interval notation, there's two of them. So as I go from the left, this is OR, separated with OR. Let's look at the interval on the left. I go from what to what? Start from the left. Negative infinity to negative 4. Let's think, parentheses or bracket? Parenthesis and negative infinity. It's filled in circle at negative 4, so bracket. And then my next interval, let's start from the left point. The left point is what? Negative 1 to infinity. Filled in circle at negative 1, so bracket. Open circle at infinity. So, infinity, you always put parenthesis. Okay.
Way to go, Paul.
Any questions on that?